Welcome to Educator.com. In today's lesson, we're going to be covering adding and subtracting rational expressions with unlike denominators. In the previous lesson, we talked about adding and subtracting rational expressions with common denominators, and now we're going to go on and talk about when you start out with unlike denominators. And in this lesson, the goal that you need to keep in mind is that we're trying to end up with a common denominator. In order to get there, we're going to start out by reviewing the idea of least common multiples and then applying that idea to polynomials. So let's just talk about regular fractions first before we go on to polynomials. Let's say you have 1/10 and 2/45, 2/45 that you want to add. You know that in order to add these, you have to find a common denominator, and you might realize what the common denominator is and be able to pretty quickly do this in your head and figure it out. But I want to bring out each of those steps because when you're working with polynomials, you need to know each step really well. Okay. In order to find the common denominator, what I need to find is the least common multiple for these two, for the two denominators. And that is what I'm going to use as my common denominator. In order to find the least common multiple, what I need to do is factor each of the denominators. So factor each denominator as far out as you can. Prime factorization. Well, 10 factors into 2 and 5. 45, it factors into 9 and 5, but I'm not done because it actually factors into 3. 9 can be further factored into 3 times 3 times 5. Now, what I need to do is find the lowest degree for each factor found in either one of them. Okay, so the least common multiple is going to equal the product of the factors found here. So for 10, I have 2. So I need to include that. I also have a 5, and I have a 5 in both of them. So I have a 5 here, I have a 5 here. I'm going to include the 5. Down here, I have 3, but it's actually 3 squared. So I need to include that. And, let's say I had a 3 up here. I would still use 3 squared because I need to have all of these factors included to end up with the least common multiple. Okay, let's look at what this product ends up being. 2 times 5 is 10, and 3 times 3 is 9, so this is 2 times 5 times 9, or 90. And what I want to do is end up with a common denominator of 90 for these. In order to do that, let's see what I would have to do. Well, let's write out the 10 in factored form and the 45. This is 2 times 5 plus 2/3 squared times 5. If I want to end up with a 90 here, I need to multiply the denominator by 9 or by 3 squared. But I can't just multiply the denominator by 3 squared. I have to multiply both the numerator and the denominator by 3 squared. Otherwise, I'm going to be changing this whole expression. Here, I have 3 squared over 3 squared. That cancels out. That's just 1. So I'm allowed to do that. Now, let's look over here. I have 2/3 squared times 5. My least common multiple involves a 3 squared. Got it. Involves a 5. Got it. But I need a 2. So I need to multiply both the numerator and the denominator by 2. So this is going to give me 9 times 1. And this is going to be 9 times 2 times 5, or 90, plus 2 times 2 is 4 over 90. Now I can add. Okay? Now, the difficult part is sometimes figuring out the least common multiple, but it really comes down to a product of all the unique factors to the highest power. So I have a 2 here, just to the power of 1. That's the highest 2 that I've got. I have a 5, It's the highest power that any of them has. For 3's, I have a 3 squared, so I need to include that as the highest power for each of that, for that factor. Okay, we can do the same with rational expressions, but now we're just working with polynomials. For example, 4 over x squared, 3x plus 15, plus 5 over x squared plus 8x plus 15. First, I'm going to factor each denominator just like I did up here to find the least common multiple. So for this first one, I have 3x plus, actually 15, 3x plus 15. And I'm going to factor that out to 3 times x plus 5. Right here, x squared plus 8x plus 15. Well, factors of 15, 1 and 15, that's going to be too large to add up to 8. So let's try 3 and 5. This could be x plus 3, x plus 5. Let's see if this checks out. X squared, outer terms, 5x, plus inner terms, 3x. That gives me 8x. That checks out. Last terms, 3 times 5 is 15. Okay, so now I want to find the LCM. So I'm going to look for the factors. I have a 3. I need to represent that. I have x plus 5. The highest degree of either of these is just to the first power. So I'm going to just put x plus 5. And I have an x plus 3. So when working with adding or subtracting, what I need to do is find the LCM and use that as the denominator. And then go on to add as we did up here. We'll get to that step in a second. But for right now, the thing that you need to just work on and realize is that you need to find the least common multiple by factoring out the two polynomials that are in the denominator, and then taking the product of each of the factors that you find here to the highest degree that you find out of either one of them. Okay. Now, once you find the least common multiple, the denominator that you want to use, that'll be your common denominator, you need to rewrite these rational expressions as equivalent rational expressions using the least common multiple. In the previous slide, I discussed how we had an example of 1/10 over plus 2/45, and we found a least common multiple of 90, and we were able to multiply the numerator and the denominator of each of these by the correct terms in order to get equivalent fractions. We're doing the same thing here, only with rational expressions. Okay, let's go ahead and look at a set of rational expressions and try this. So I'm asked to add these, and I check and I see I don't have common denominator. I don't even have an additive inverse to work with. I have two completely different denominators. So first, find the LCM. And in order to do that, I'm going to factor x squared minus 1 and 2x plus 2. This is the difference of two squares, and it factors out to x plus 1, x minus 1. Here I have a greatest common factor of 2 that I can pull out to get x plus 1. The LCM, I'm going to look up here. I have a factor of x plus 1. I have an x plus 1 here. The greatest power that it's found to in either one is just 1. So I just put x plus 1. Now, if I had x plus 1 times x plus 1 times x minus 1, I would actually write x plus 1 squared down here. If I had it 3 times, I would have to make it cubed. Okay, so I have x plus 1. And I have x minus 1. And I also have a 2. So my least common multiple is actually 2 times x plus 1 times x minus 1. Now I need to turn these into equivalent rational expressions using the LCM as the denominator. So I have this LCM. I'm going to rewrite it, putting the 2 out front. Now, starting with 3x plus 1 over x squared minus 1. what I need to do is get this so that I have the denominator as the LCM. Remember that we factored this out already, so I'm going to write it in factored form to make it clear what I have and what I'm missing in terms of the LCM. Well, if I look here, what I am missing, the only thing I'm missing is the 2. Therefore, what I need to do is multiply both the numerator and the denominator by 2. So that gives me 3x times 2 is 6x plus 2, 1 times 2, all over the LCM. So now I've got my LCM. So this is the numerator. The numerator now, because I multiplied by 2, and then it's got the common denominator. So this was my expression on the left. Now, my other rational expression is 5x, 5 over 2x plus 2. Writing that in its factored form, because I factored out 2x plus 2, gives me 5 over 2 times x plus 1. Now that this is in factored form, I can just look and see, okay, what's missing? I've got a 2, I've got an x plus 1, I'm missing an x minus 1. So to convert this into an equivalent rational expression with the LCM, I've got to multiply by x minus 1. And I'm allowed to do this because I'm multiplying the numerator and the denominator by the same thing, so really I'm just multiplying by 1. 5 times x minus 1, that's 5x minus 5 over 2 times x plus 1 times x minus 1. Okay, now that I've done all this, what I've ended up with is, for this expression on the left, I've ended up with 6x plus 2 over the LCM. For the expression on the right, I've ended up with 5x minus 5 over the LCM. Now that these are written using the LCM, I've got a common denominator. I can go back and proceed as usual with addition, with adding 2 rational expressions. Okay, adding the numerators, 6x plus 2 plus 5x minus 5, and this is all over the common denominator. X 2 times x plus 1 times x minus 1. Doing some simplification, I have 6x and 5x, so those add up to 11x. 2 minus 5 is negative 3 over my common denominator here. Gives me this. Okay, so this is the toughest step, is, after you've figured out the LCM, making sure that you can correctly convert the 2 rational expressions into equivalent expressions using the LCM as the denominator. So in order to do that, write the denominator in factored form, and then look at your LCM and see what's missing in the denominator. So what was missing when I factored this out was the 2. So I'm going to multiply the numerator and the denominator by that 2. For this second expression, when the denominator is in factored form, I had 2 times x plus 1. So what was missing to give me the LCM is x minus 1. So I multiply both the numerator and the denominator by x minus 1 to give me this. Now I've got 2 expressions with a common denominator, and then I can add them up using previous techniques. Okay, to summarize, to add or subtract 2 rational expressions with unlike denominators, first, find the LCM of the denominators. Once you've done that, you're going to change each rational expression into an equivalent one with the LCM as the denominator. I did that in the previous slide. After that, you've got a common denominator, which is the LCM. You simply add or subtract the expressions, which now have like denominators. And finally, simplify if possible. Okay, first example, we're asked to just find the LCM. So find the LCM of x squared plus x minus 12 and x squared minus 16. So we're not even working with rational expressions yet. We're just talking about finding the LCM of two polynomials. And that technique is what allows us to find common denominators when we're working with rational expressions with unlike denominators. So in order to find the LCM, I'm going to factor both of these polynomials. Okay, since there's a negative here, I know that I've got a positive and a negative. And I'm going to think about what my factors of 12 are. 1 times 12. I've got 2 times 6 and 3 times 4. And I know that since the products of these, the outer and the inner two terms, the products of those, are going to add up just to 1, just to x. So I know I'm going to be working with factors that are close together. 1 and 12 aren't close together. 2 and 6 aren't that close together. 3 and 4 is my best bet. So if I go ahead and try, I want to make the larger number positive because x is positive. I'm going to try this and see if it works. So this gives me x times x is x squared. X times negative 3 is negative 3x plus 4x. So negative 3x plus 4x is x. So that's correct. Last terms. 4 times negative 3 is negative 12. So I factored correctly. X squared minus 16 is the difference of two squares. So that's x plus 4, x minus 4. Okay, to find the LCM, I'm going to look through and see what factors I have and what the highest power any of those factors is taken to. I have an x plus 4. It's the first power. Same thing here. That's the highest power for that factor. Okay, I have an x minus 3 up here, so I have to include that. Done with that. Did the x plus 4, and I have an x minus 4. So this is the LCM of these two polynomials, and I found that by factoring out each polynomial and taking each of the factors that I see to the highest power that they're present in either one of these polynomials. And if these were in rational expressions, if these were denominators in rational expressions, I could then use this LCM to form a common denominator. Okay, in this example, we have unlike denominators, and they're not additive inverses, so we need to find the LCM, convert expressions to equivalent expressions with the LCM as the denominators. Then we can add and then simplify. First, find the LCM by factoring 3y minus 6 and 4y minus 8. Okay, I'm factoring the denominators to get 3 times y minus 2. And in this other expression, I can factor out a 4 to give me 4 times y minus 2. The LCM is going to be the product of the factors here raised to the highest power that they're found in either set of factors. I have a 3. I also have a 4. I have y minus 2, and for all of these factors, the highest power that they're present for either one is just 1. So I only have them represented once each. Now, I could rewrite this as 12 times y minus 2, but I'm going to leave it in this form because when I'm on step 2 and I'm converting these expressions, I really want to see what the LCM is composed of and what I'm missing from each expression in the denominator in order to find that LCM, to convert to the LCM. So I'm going to rewrite these, 3y, and I'm going to write the denominator in the factored form. Again, my goal is just to figure out what's going on and what I'm missing as far as the LCM. So that's 3y over 3 times y minus 2 plus negative 6 over 4 times y minus 2. Okay. Looking at this first rational expression, I have 3 times y minus 2. For the LCM, I need 3 times 4 times y minus 2. Therefore, I need to multiply both the numerator and the denominator times 4, which I'm allowed to do because this just cancels out to 1. It's just multiplying by 1. In the second expression, I have negative 6 over 4 times y minus 2. Well, in the LCM, I have a 4, I have y minus 2, but I'm missing a 3. So I need to multiply both the numerator and the denominator by 3. Next step is just to go ahead and multiply this out. That gives me 12y over 12 times y minus 2. In my second expression, negative 6 times 3 is negative 18. 4 times 3, 12y minus 2. Now I've got common denominators, so I can add these two rational expressions. I'm just adding fractions with like denominators. This is going to give me 12y plus negative 18. I can write that as minus 18 over the common denominator, 12 times y minus 2. So I added, my last step is to simplify. And I do see that I can factor these out with a common factor of 6. So I'm going to rewrite these as 6 times 2y minus 3 over, well, 12 is really just 6 times 2 times y minus 2. My 6's cancel. This is 2y minus 3 over 2 times y minus 2. And I can't go any farther with simplifying that. So again, I found my LCM for the denominators. I converted these two expressions into equivalent rational expressions with the LCM as the common denominator. Now that I have a common denominator, I was able to add and then finally simplify. Example 3. Again, adding, or in this case, subtracting rational expressions with unlike denominators. First step, find the LCM of the two denominators by factoring. Begin by factoring both denominators and then find the LCM. Okay, so I'm looking at the first one, 2z squared plus z minus 6. First thing I need to do is factor that out, and I've got 2z as my first term. I'm going to have z here as my second term, and I do have a negative, so it's going to be, one of them is going to be negative, one of them is going to be positive. So let me do a little work over here. Factors of 6, 1 and 6, 2 and 3. Now, because this ends up being z, I'm going to want factors that are close together. So I'm going to try 2 and 3. And I could have 2z plus 2, and I could try z minus 3. I know the first terms work and the last terms work. Let's see about the middle terms. That would give me negative 6z plus 2z. That's negative 4z. That doesn't work. Okay, so let's try something else. 2z plus 3, z minus 2. Okay, I know my first terms work, I know my last terms work, my middle terms. This is going to give me outer, negative 4z, and inner, 3z. Okay, so that gives me negative z. I'm pretty close, but I have a negative and I want a positive. So what I'm going to do instead is try this with a negative here. I'm going to reverse the sign on this first one. All right, now I'm going to get 2z squared, my outer terms, 6z. My inner terms, actually, correction, that should be a 2. Okay? Outer terms, 2z times 2, that's 4z. Inner term, 3z. It's going to give me a middle term of z. That is correct. So this is a correct factorization. So 2z minus 3 times z plus 2. First is 2z squared. Outer terms 4z minus 3z to give a z. Last term, negative 6. So that's factored out. I can't actually factor this out any farther. So this first one was quite a bit of work, but the second one is no work at all. It's just 2z minus 3. Now, my least common multiple here, I have a 2z minus 3 up here and down here. I also have a z plus 2. Notice that my least common multiple is actually the same as the factorization of this one. So this one already has the least common multiple. I'm not going to have to do anything with that one. But just to make it clear, let's go ahead and rewrite both of these with the denominators in their factored forms. Okay, minus z plus 4 over 2z minus 3. The LCM for this first one, I already have the LCM in the denominator of this first expression. I don't need to do anything to it. In the second expression, I have the 2z minus 3, but I'm missing z plus 2. Therefore, I need to multiply both the numerator and the denominator times z plus 2. Okay. Doing some simplification and then adding. This gives me 2z minus 3 in the denominator, z plus 2. That's my LCM. Now I need to multiply all this out. This is z squared. Outer, I get 2z. Inner is 4z, so that's plus 6z, plus 8. 4 times 2 is 8. All over the LCM, the common denominator. Now that I have a common denominator, I can go ahead and add. Z plus 2 plus, so I changed this to a plus. That means I'm going to have to make each of these the opposite sign. So that's going to give me a negative z squared plus negative 6z plus negative 8. Okay? All over 2z minus 3 over z plus 2. Combining like terms, I have negative z squared then I'm going to look at my z terms. I have a z minus 6z. That's going to give me negative 5z. I have a 2 minus 8. That's negative 6. All over 2z minus 3, z plus 2. Okay. Now, I can factor out a negative 1 here. So let's work on factoring this to see if we can do some simplification. I can factor out a negative 1, and that's going to give me negative z squared plus 5z plus 6. And I can try to factor this, and this does factor to z plus 3, z plus 2. Checking that, z squared, outer terms 2z, inner terms 3z, so that's 5z, last terms 6. So I can factor this out. I've added, now I'm simplifying to get z plus 3. So this is separate. Some work on the side, z plus 3, z plus 2, over 2z minus 3 times z plus 2. I see that I actually do have a common factor, and this is actually all negative. This is negative, this is negative, so I do have a negative sign here. Those cancel out. Rewriting this as negative z plus 3 over 2z minus 3. And that's my answer. So this was pretty complex. I first had to factor out both of the denominators. And when I did that, I found that the LCM was 2z minus 3 times z plus 2, which is actually this denominator. Therefore, this rational expression already had the LCM in the denominator. I left that alone. For the second expression, it had the 2z minus 3, but was missing z plus 2. Therefore, I multiplied both the numerator and the denominator by that. And when I multiplied out the numerator, I came up with z squared plus 6z plus 8. Added those because they're over a common denominator. When I did that, I came up with negative z squared minus 5z minus 6, factored out the negative sign, and then factored this polynomial to get z plus negative z plus 3 times z plus 2. So that's my numerator, my denominator, canceled out the common factor, and came up with this final answer as a subtraction. Okay, again, adding with unlike denominators, starting out by factoring both denominators. I have a negative here, so that means I have a positive, and then the other binomial is going to have a negative. Thinking of factors of 18, 1 and 18, 2 and 9, and 3 and 6. Now, my middle term is not very large, so I'm going to pick a set of factors that is close together. That would be 3 and 6. And I'm going to make the larger one a positive, since the middle term is a positive. So I'm going to try this and see if it works. First term, w squared. Outer term, that's negative 3w. Inner term, 6w. So minus 3w plus 6w does give me a middle term of 3w. 6 times negative 3 is negative 18. So I have the factorization of that first denominator. Second one, 2w squared minus 7w plus 3. Okay, I have a positive here, and I actually have a negative here, which tells me that I've got two negatives. Since this is 2w squared, I need a 2w here and a w here. And I have 3, so that doesn't leave me with a lot of choices for factors. So I'm going to go ahead, just for 3, I've got 1 and 3. So I'm going to try the 1 here and the 3 here and check this out. First terms, 2w squared. Outer, negative 6w. Inner, negative w. Negative 6w plus negative w, negative 7w. Last, negative w times negative 3, which is 3. So this factorization checks out. I've got the denominators factored. I'm going to find the least common multiple. Okay, up here I have w plus 6, and I have a w minus 3. So the w minus 3 is taken care of. Down here, though, I also have 2w minus 1. So this is my least common multiple. Now, I'm going to rewrite these rational expressions, putting the denominators in their factored form so I can see what I need to multiply by to get my least common multiples in the denominator. Factorization of this trinomial is w plus 6, w minus 3. The second one factored out to 2w minus 1 times w minus 3. Okay. Now, looking at what I'm missing. Here, I have w plus 6 and w minus 3. I'm missing 2w minus 1. So I need to multiply both the numerator and the denominator by 2w minus 1. Over here, I've got the 2w minus 1 and the w minus 3, but I'm missing w plus 6. So I'm going to go ahead and multiply both the numerator and the denominator by that. Now I need to do some simplification of these numerators and then add. So 2w minus 1 times w minus 4. That's 2w times w is 2w squared. Outer term, that is going to be negative 8w. Inner, negative w. Last, negative 1 times negative 4 is plus 4. Okay. Over here, 2w times w is going to give me 2w squared. Outer term, is going to be 12w, inner term 3w, last term 18. Now I've got my denominator, which is the LCM. All right, so now I'm going to go ahead and add the numerators and put them over their common denominators. Common denominator, I'll just write that in, so that's taken care of. Numerators, I can add since these have a common denominator. I have 2w squared and another w squared term, 2w squared. 2 plus 2, w squared, that is 4w squared. Now, my terms with w's in them. I have negative 8w minus w. That gives me negative 9. Plus 12w. Negative 9w plus 12w is 3w. Plus 3w, 6w. Okay, now I have 4, just the constant 4, plus 18. And that is going to give me 22. Now, you could try to factor this and see if there are common factors. But if you did, you would end up finding out that there are no common factors. This cannot be simplified, so we can't take this problem any farther. So again, we handled these by finding the least common multiple, using that as the denominator by writing equivalent rational expressions with the LCM in the denominator, went ahead and multiplied out my numerators and added. And this cannot be simplified any further. So in today's lesson, we learned about adding rational expressions with unlike denominators. I'll see you again at educator.com.